Okay guys, today we have to explore another good concept where we kind of combine both the dot product and the cross product in one particular thing. So we call this the triple scalar product. So let's say we have three vectors, u, v and w. So the product u, first of all, let's start with the cross product. So the cross product of u cross v, and when we get that answer, of course that answer will be a vector, right? Then after we get that answer, then we dot that with third vector w. So this kind of a product is called the triple product. So it's called the triple scalar product because at the end of the day we're gonna have a dot product there, and then the answer is gonna be a scalar quantity. So we're not going to end up with a vector. Okay, so we can define a formula for that. So if we have the triple product u cross v dot w, we can get the magnitude of that. So we can get the magnitude of that in form of so if you get the magnitude of u cross v, and then you multiply that with the magnitude of w, then you get the cosine theta. So in this particular case, let's just for us to understand what this theta is, let's look at this diagram here. So the diagram, we have a box. Now this box has got sides which are parallelograms. So this is called a parallel pipe, or maybe you can call it a parallelogram sided box. So we have a box. So then maybe that's even the reason as to why this is also called the box product. So just to visualize that, so let's say we have two vectors. Which lie on the plane. So we have u. Remember, we have u there. We have u in that particular direction, and then v should be in that particular direction. So the u and v lie on this particular plane. They lie on the surface. So if you get the cross product, remember what we looked at last time. The answer is going to be a vector protruding which is perpendicular to the surface, right? So that will be our vector u cross v. So let's say we have another vector w. So now you can see that actually now w and u cross v are the two vectors which make the angle theta. So theta is the angle between w and the vector u cross v. Okay, so it should be noted that the angle theta is between w and the vector u cross v. Okay, so it's also called the box product because we're talking about a parallelogram sided box. And apart from that, you can show using some geometry and some trig, you can show that this relationship here holds. Okay, so we continue. So maybe the only thing we can know that if you want to find the volume of a parallel piped or a parallelogram sided box, you can define two vectors. You can define three vectors. Once you have those three vectors coming from a same point, then you can get this. You can get that triple product. Then the magnitude of the triple product will give you the volume of the parallel piped. Okay. So now, how do we go about evaluating the triple product? So you can show. I'm not going to show in this particular lesson. You can show that u cross v dot w. At the end of the day, you're gonna have it's same as just getting the determinant of a matrix, which is formed by, first of all, you get the components of u, which are u1, u2, u3 in as the first row, as the entries of the first row. Then you get the components of v, v1, v2, v3 as the entries of the first row, and then also the components of w as the entries of the third row. So it's as simple as that. That's how easy it is to get the triple product. So that's that. So then for now, I think maybe we can go through an example. So we have an example here. So in this example, we should find the volume of the box or a parallel piped, determined by three vectors u, v, and w. So how do we go about doing this? So remember, the volume is just the magnitude of the triple product. So the first thing we can do maybe is first of all, let's get the triple product. But of course, we already have a theorem there which will help us to get the triple product. So we can see that U cross V, okay, that cross W. So we have vectors. I'm just underlining them, show that we are talking about vectors. So this is equals to so all we have to do now is just put the components of each of these vectors as rows. So here the components, so we start with the components of U, as you can see there. So the components of U, the first one is 1. So we have 1, then we have 2, and when we have -1, then we have -2 for that one. Then of course the J is missing there, so we have a 0, and then the K is 3, so we have 3 there. Then here we have the I is missing, so 0. Then here we have a 7 on the J's, and then we have -4. So all we have to do is just get the magnitude of this, the determinant of this matrix, then we are home and dry. Okay, so remember the determinant can be negative or positive, but then okay, let's just do it. So how do we get the determinant? So we use the first row as entries, as pivots. So we start with the first pivot. So we start with the first pivot 1. So when we have 1 as a first pivot, and we know that when we have 1, that will cancel, so we remain with the matrix 0, 3, 7, -4. Okay, then of course the second one will be okay, plus 2, but of course the second one will be negative, because remember the pivots change sign, so plus, positive, negative, positive. So you just have to add on that sign there. So it'll be that. So we cancel that, so we remain with -2, 3 there, 0, and -4. Okay, then so minus, plus, minus. Of course, I'm gonna have a plus here. Then the itself is -1, so it is still -1. Okay, then of course we are cancelling that, so we remain with -2, 0, 0, 0, 7. So that's what we have there. Okay, we can continue. Okay, so what we have here is 1. So 0 times -4, we have 0. So 0 minus 7 times 3, we have 21. Then here is -2. So -2 times -4, that's +8. Minus 0 times 3, that's 0. That's a -1 there. Then -2 times 7, we have -14. But of course minus 0. So this is going to give us -21 there. There minus 2 times 6. 2 times 8, we have 16. Then minus 1 times so that plus 14. So of course then minus 21 plus 14, that's -7. So -7 minus 6 minus 16. So then we can now find so minus 7 minus 16. So we're just basically adding this, so we get minus 23. So that's our triple product. But then the volume, remember the volume is the magnitude of the triple product. Okay, the magnitude of the triple product dot W. Okay, so the triple product itself is minus 23, so that we get the absolute value of minus 23. So which means that the volume is 23. We don't have units, so just say units to the power 3 cube, 3 to the, okay. So this is how we go about employing the triple product, and this is how we also get the volume of the of any box given the triple product. Okay guys, thank you, see you in the next video.